Here we have the 4.2 worksheet K video key. So the first problem they provide us with the fact that segment RX is congruent to segment SX and QX is congruent to TX. And they've asked us to prove that triangle QXR is congruent to triangle TXS. So naturally we start the proof by restating our given. So RX is congruent to SX, and we've got QX is congruent to TX. And that's your given statement. From there, we've got two sides, and we should now draw our attention back to the diagram. We have to find something here we can prove easily. Well, I recognize vertical angles here and here. So my next step is going to be that angle RXQ is congruent to angle SXT by the vertical angle theorem, or VAT. Now that I've done that, I have enough information to show that the two triangles QXR and triangle TXS are congruent by side angle side triangle congruence. So questions 2 and 3 are actually directly out of your notes. Here you're just listing corresponding pieces that they provided you with, so you're filling in the blanks to see what you were provided. And then in question 2, you still need angle B is congruent to angle G to use side angle side. And for question 3, you either need angle Z and T are congruent, or XY and segment RS are congruent in order to prove side angle side. For question 4, we can use the reflexive property here to prove that this segment is congruent to itself. So here we would get side, side, side. In question 5, we could use vertical angles, so that gives us side angle side. And then here, we don't have enough information. We could get this piece here, but that's not enough. We need the outer pieces in order to use side angle side, or all the other sides for side, side, side. So this is not enough info. Question 7, they've given us another two-column proof. They give us that CO is equal to NA and OA is equal to CN. So they're telling us the segments are congruent. They want us to prove that triangle CAN is congruent to triangle AON. So we're going to start by restating our given. From there, we then have to look at our diagram, and we should notice that we have a segment that is a part of both triangles. In this case, CA is congruent to CA. And we know this because of the reflexive property. And with that, we now have enough to prove the two triangles congruent. So triangle CAN is congruent to triangle AON by side, 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 triangle congruence. In question 7, they've asked us to do another two-column proof. This time they're telling us AE is congruent to LP, and angle EAL is congruent to angle PLA. So once again, we restart our problem by stating the given. And once again, we don't have any special words in our given statement. So we look at our diagram and we notice we have a reflexive property at play here. So step 2 would be to say that AL is congruent to AL by the reflexive property. From there, we now have enough to show that triangle EAL is congruent to triangle PLA by side angle side triangle congruence. So for question 9, you're merely using the distance formula to determine whether or not the corresponding sides in this particular triangle are congruent. So you're finding the measure of the sides using the distance formula and showing if their measures are the same. Question 10, can you prove the triangle is congruent? If so, write a congruence statement and name the postulate used. So in this particular problem, we can prove them congruent. So we would say triangle QRS is congruent to triangle YXW. And the ordering here matters, and we know this by side, angle, side. In question 11, this is not enough info because we would need to know an angle or the additional side. We don't have that. Question 12, we can use the reflexive property here. So we get triangle CNA is congruent to triangle AOC by side, side, side congruence. 13, suppose AB is congruent to DE, B is congruent to E, and AB is congruent to BC. Is ABC congruent to DEF? Explain. So if we were to draw this particular triangles, we've got triangle, let's say it's not a good triangle, but there we go. A, B, C, and then we've got triangle D, E, F. Well, we mark what we know. AB is congruent to DE, and AB is congruent to BC. We also know that B is congruent to E. Well, right now we have side and an angle at best. That's not enough information. We would actually need to know that, let's say, BC is congruent to EF in order to even think about using side, angle, side. All right, for question 14, we're given that BD is the perpendicular bisector of AC. We saw a question just like this in our notes. It's actually the same question, but I want to emphasize the idea of looking at key words. In this case, perpendicular bisector is a key word. So as we start this proof, we restate our given. But in the second step after that, we start applying the keywords in the given. The first one they apply is bisector. If BD is the bisector of AC, it's creating congruent segments in AD and DC. So they say so in the proof and use the definition of bisector. They also then use the term perpendicular. Perpendicular means to create right angles. So that tells us that angle ADB and angle CDB should be 90 degrees. So they're both right angles. So that's step 3. If those two angles are both 90 degrees, that means they're equal. So our fourth step can be to say that ADB is congruent to angle CDB by definition of right angles. From there, we still need another piece of information, so we go back to our diagram. We should notice that the two triangles are sharing side DB. So we can say that DB is congruent to DB by the reflexive property. With this, we now have enough information to say that triangle BAD is congruent to triangle BCD by side, angle, side congruence. Our last proof, question 15. They've given us that PX is congruent to PY and that ZP bisects XY. So we've got a segment, we got a keyword here, bisects is a keyword. And so we're going to utilize that. So what we're seeing is that segment ZP is cutting XY into two equal parts. So we've got equal segments being created here and here. So we're going to use that in our proof in a second. They've asked us to prove that triangle PXM, which is actually this smaller triangle here, is congruent to PYM. So in reality, we actually don't need this piece of the problem here. This piece of the diagram doesn't help us. So we can kind of forget about it for the time being. So as we were saying before, ZP, or in this case PM because Z was over here, bisects this segment here. So let's start by restating our given, and then we'll apply that particular key phrase. All right, so now that we have the given taken care of, we're going to apply that key phrase. Well, because ZP bisects XY, we know that XM is congruent to MY, because to bisect it means to create two equal parts. And so this is just definition of bisector. All right, now we have two sets of sides, but maybe we need another, either an angle or a side. Well, notice that the two triangles we're trying to solve for share this common side of PM. So we can say PM is congruent to PM by the reflexive property. And that gives us just enough information to prove that triangle PXM is congruent to triangle PYM by side, 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 triangle congruence.